Now I want to talk about projectile motion. Projectile motion is just a super fancy way of saying stuff going through the air. It could be somebody tossing a chalk thing in the air, hitting a basketball, throwing a basketball, hitting a baseball, golf ball, a cannon, a gun, fireworks, anything that flies through the air follows the same general pattern. It'll go up for a little while, and then eventually it'll slow down, stop rising, and then start falling again until it hits the ground. This shape is a parabola. Any object flying through the air will follow the path of a parabola. Now, it may not be a perfect parabola, but it's going to be very, very close to it. And since we have this parabola shape, we can find an equation that describes that path. We can find an equation that gives the height as a function of time. That as time goes on, the height increases and then eventually starts decreasing again. So we need an equation that can give us this function. We need an equation that can give us the height, usually measured in feet or meters, usually measured in one or the other of those, and t equals time. Seconds. Pretty much always seconds. We're not going to be talking about hours or minutes in this case. The function that we can use, so h of t, remember that function notation, we have the height as a function of time, looks like this. It's always of this form, negative 1/2 a t squared plus that thing times t plus that thing. This is pronounced v naught. That's actually a little zero there, so v0. This would be h0. We'll get back to what these things mean in a moment. I want to start here at a. A, in this case, represents acceleration. Acceleration specifically due to gravity. You all know gravity. What goes up must come down. That's the whole idea. Gravity is what pulls stuff to the center of the earth. And if you're in a free-for-all, if you've ever been skydiving, and I wonder really how many of you actually have been skydiving, I certainly haven't, and I probably never will. It kind of freaks me out. But anyway, if you go skydiving, you accelerate. You go faster. Accelerating means you speed up. And if you are falling, you'll keep speeding up. You might have heard of a thing called terminal velocity, which means that there is some kind of upper limit on how fast you'll go due to the friction of the air against your body. But the point is, gravity makes you speed up. Really, this value right there, that a, pretty much only takes one of two values. The values for a are either going to be 32, if we're talking about feet, or 9.8 if height is measured in meters. You're only ever going to have an acceleration that's one of these two values, assuming you're on Earth. If you're on other planets, then, you know, all bets are off. If you're on the moon or on Mars, these numbers are going to be different. These are true for the moon. What this means is that this first term is pretty much always going to be either negative 16 t squared, since half of 16 is, or half of 32 is 16, or it's going to be negative 4.9 t squared if we're talking about meters. This first term is always going to be one of these two things. And it depends on if you're talking about feet or meters, exactly which of those it's going to be, but it's always going to be one of those. So acceleration, a is the acceleration, is always one of these numbers. Now, that second thing that we were talking about here, this v naught, this stands for something called our initial velocity. That's what v stands for. Velocity is kind of a fancy way of describing speed. Once you get to physics, you'll learn about what exactly velocity is, but it's speed. It's how fast you're going. Specifically, it's how fast you're going at time zero. Imagine you're keeping track of how far a baseball is going, how far a golf ball is going by using a stopwatch. the moment you hit that stopwatch, that's time 0. Because no time has actually passed until you've hit that stopwatch. Once you start it, that's time 0. So what this is how fast whatever it is going, whatever the thing is going right at the beginning, right from the get-go. So right when you hit the golf ball, right when you toss the chalk in the air, that moment that you start the stopwatch, that's what we mean by initial velocity. And so h equals 0, that's for the initial height. Now, initial velocity can be measured in feet per second or meters per second. Height will be measured in feet or meters. I should say feet or meters. Let me write that better. Feet or meters. There we go. And however these things are measured, velocity and height, however those things are measured, that determines which of these two numbers you'll use. If the speed and height are in meters per second and meters, then we'll use 9.8 for A. If speed and height are measured in feet and feet per second, then we'll use the 32. But the point is, the initial velocity is that first moment, the second you hit the stopwatch. That's how fast whatever it is you're tracking is going. The initial height is how high it is. The ground, of course, is 0. Usually we're talking about its height over the ground. So if we're talking about a golf ball or a model rocket or a space shuttle or some other thing that's starting on the ground, the initial height would be 0. And so you would just end up with that -1/2 at squared plus v naught t. But if you are, say, hitting a baseball or shooting a basket or throwing a dart or frisbee or something like that, then this height will be different. You know, it'll be some amount off the ground. If you're hitting a golf ball off the edge of a building, you know, then your height will also be not 0 because you'll be going up and then the golf ball would kind of go down below where you were. So whatever the starting height is and whatever the starting speed, use starting if initial is a little bit of a tricky word. The start height and the starting speed, those are what you fill into that equation there. In the next video, we'll see an example, but this will get you perhaps enough to get started, or at least answer some of those video questions.